Let me ask you a very common question. If the second derivative is equal to 0, does it mean the point is a point of inflection? Take a moment to think. Is the answer yes or no? Most students will say yes, but this is not always correct. It is a common conceptual error. Hello everyone. If you are first time here, welcome to DOESN Cafe, our online learning space. So in this lesson, let me show you why this is not correct. Let's look at this function, y equals to x cubed. Now the first derivative is 3x², and the second derivative is 6x. Now I'm going to set dy dx equals to 0. This will give us the stationary point, and we will get x equals to 0. And I sub this value into the second derivative, right? We will also get equals to 0. So for such case, based on the graph, you can see, yes, it is indeed point of inflection. So if I'm going to take a look at the gradient function on both sides, you'll notice that both value for dy dx are greater than 0. How about this function, y equals to x to the power of 4? The first derivative, we get 4x cubed, and the second derivative is 12x². Now again, I'm going to set dy dx equals to 0 to find the stationary point, and I again will get x equals to 0. And my second derivative will also be equals to 0. And what happened is a lot of students will stop here and say that this is a point of inflection. But is it really true? If you take a look at the graph, it is quite obvious that this is not the point of inflection. So which means we are not done yet. So what we need to do here is we need to check the sign for the gradient function. So if I'm going to check the dy dx on the left side of the function, I get dy dx less than 0, and on the right side, I will get dy dx which is greater than 0. So what happened here is there is a change of sign for the gradient function. So in this case, this is what we call the first derivative test, or in some cases is called the sign test. Now this is a very important concept that everybody must know. So the key idea here is this. For a point to be a point of inflection, two things must happen. First, the second derivative is 0. And second, the signs for the dy dx must remain unchanged, just like what we have seen in the very first example. So to conclude, if we see that the both signs for the gradient function, they are negative, so in this case, there is no change in sign, we can conclude that it is a point of inflection. Or it could be the other way around, whereby the gradient function, right, they are both positive. So in this case, again, there is no change in the sign for dy dx. So again, this is a point of inflection. Therefore, in the exam, always follow these steps. Whenever you see that the second derivative is equal to 0, never conclude that it is always a point of inflection. Right? What you need is the second step, which is to check and do a sign test. Right? The sign test for dy dx. Only if the sign remain unchanged, then you can conclude that it is a point of inflection. All right, but the moment you see that the sign changes, so in this case, all right, the sign changes from negative to positive, all right, you will see that we actually get a minimum turning point. All right, so similarly, if the sign changes from positive to negative, all right, you will get to see that we actually have a maximum turning point. So it is quite clear that it will not be a point of inflection. So never skip this sign test. All right, never skip this test. So therefore, next time when you see that the second derivative is equal to 0, don't jump into the conclusion. Always check the sign test. Thank you for watching this video. I hope you found this useful. If this helped you, please like and share the video. See you in my next lesson. Bye.